Good afternoon and welcome to Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today, we're discussing Rutherford's model of the atom. At the start of the 20th century, the prevailing model of the atom was that of J.J. Thomson's plum pudding model. This atomic model had spheres of positive charge with negatively charged particles dotted throughout. An advantage of this model is that it provided a way for atoms to gain and lose charge, forming ions that were being observed by researchers. Ernest Rutherford had already done substantial work related to radioactivity and charged particles, and already had a Nobel Prize under his belt when he and his team turned their attention to the atom. Their experiment was to take an incredibly thin sheet of gold foil and fire alpha particles at it. Alpha particles are large, positively charged particles. They have 2 protons and 2 neutrons. If J.J. Thomson's model was correct, these particles should either rip straight through the foil or be absorbed in some manner. However, this is not what they observed. Instead, they saw that while a lot of the particles did indeed go straight through the foil, some were deflected slightly, while others ricocheted back at wild angles that they really were not expecting. Rutherford remarked that it was like firing a cannon at a sheet of tissue paper and having the ball bounce back towards them. None of these observations could be accounted for using the plum pudding model, so a different theory had to be devised. For this, they thought about the fact that alpha particles are positively charged. So if you were to take most of the mass inside the atom and put it down into a small, dense, positively charged nucleus, then any alpha particle that started to come close to it would be pushed away, deflected by the like charges. And any particle that directly struck the nucleus would bounce back. You could think of this atomic model as being similar to our solar system. Most of the mass is in the center, the sun, and then around it we have the planets, the electrons orbiting. And most of the system is just simply empty space. Rutherford would go on to further refine this model, putting protons and neutrons in the nucleus, allowing for atoms with different weights but the same characteristics. While a major advance in atomic theory, Rutherford's model was not without its flaws. For example, it couldn't say where the electrons would be. It also couldn't explain why different colored flames were observed when atoms were heated in a Bunsen burner. Answers to those questions would start when Niels Bohr further refined this atomic model. However, that is a story for another day. I hope you have enjoyed this video, and if you have, please click like, subscribe, and share it with your friends. And if there is any topic you would like to see discussed in a future video, please put it in the comments below. Thank you, and I hope you have a wonderful rest of your day.